This is for your 12 methods that comes out of 10G, question number 7. It's about finding coordinates of turning points, natures of turning points, and equations of tangents. It's questionable whether this is a tech allowed or tech free question. Finding the nature of the turning points where we have a family of curves is really quite difficult to do. So I'm probably likely to do this one with tech allowed, and I'll show tech free for part of this, but I'll also do tech allowed there as well. So it's really probably a tech allowed question. Okay, so I've got this cubic. I know that at x minus a squared, x minus 1, that's a tut or a bounce at x equals a, and that's a cut at x equals 1, and it is a positive cubic. And I know that a is bigger than 1, therefore here is my 1, there is my a, and I'm going to come through here and cut there, come back and bounce. So find the coordinates of the turning points. Well, I know that this coordinate is a and 0, so I found one of them. This one here will be between 1 and a. So I'll take the derivative. So I know that f of x equals x minus a squared, x minus 1. So that's going to be u and that's going to be v using the product rule. So u equals x minus a squared, u dash is 2, x minus a to the 1, and the derivative of the inside is 1. And v is x minus 1, so v dash is 1. So f dash is going to equal this times this, so 2 x minus a, x minus 1, plus this times this, x minus a squared. And I can see an x minus a in each of those, so x minus a comes out, and that leaves me with two lots of x minus 1, so 2x minus 2, plus x minus a, which is x minus a, 2x plus x is 3x, minus 2 minus a, and that's going to be the derivative. If I set that equal to 0, I get x equals a, and that's going to give me the one that I already know. And x is going to equal 2 plus a on 3. So my second point is at 2 plus a on 3, and then I need to find the y coordinate. This is why this is probably a tech allowed question. So f of 2 plus a on 3 is going to equal, what have I got, x minus a squared. So 2 plus a on 3 minus a squared, 2 plus a on 3 minus 1, which is the same as 2/3 plus a thirds minus 3a on 3 all squared, and 2/3 plus a on 3 minus 3 on 3 to the power 1, which is 2 minus 2a on 3 squared, and 3 minus 1, a minus 1 on 3, which is going to be 2/3 1 minus a squared, 1/3 a minus 1. Which is the same as minus 2/3 a minus 1 squared. So I've taken the negative out of there, so I can combine it with this one over here, times 1/3 a minus 1. And when I square these, I get 4 on 9 times 3, 27 a minus 1 cubed. So 4 on 27 a minus 1 cubed is the y coordinate. So they are my two stationary points. This one, or turning points, and this one. To the next part of the question, state the nature of the turning points. I'll show you my problem. So if I do a sign diagram, I know that when x equals 2 plus a on 3, the gradient is 0. When x equals a, the gradient is 0. I can find a value to the left of this, for example 1, and I can put 1 in here, and if I do the gradient when x equals 1, I get 1 minus a times 3 minus 2 minus a, which is 1 minus a times 1 minus a, which is 1 minus a squared, and that will be positive because then x squared is positive, so it looks like this. I now have to find a value in between 2/3 plus a on 3 and a. And I've got to find a value that sits in between there, and then I've got to find a value that is bigger than a, so I might go a plus 1 for this side. If I do a plus 1, I'm going to do a plus 1 minus a times 3 times a plus 1 minus 2 minus a, which is 1 times 3a plus 3 minus 2 minus a. 3a minus a is 2a plus 1. Since a is bigger than 1, this is positive, and times 1 is positive, so end up with a positive. Here's my problem, finding something that is in between 2/3 plus a on 3 and a. So how do I find a value that is in between this value and this value? Well, if I add these together and divide by 2, that will give me halfway in between them. So a plus 2 on 3 plus a all on 2 should be dead middle between the two of them, and that should give me a value somewhere here. So that gives me a plus 2 on 6 plus a on 2, which is a plus 2 plus 3a all on 6, which is 4a plus 2 on 6, which is 2a plus 1 on 3. Now you can see why this is really a calculator question, and I might now bring up my calculator to find out what that is. So I know my derivative is going to equal x minus a and open bracket, forgotten it, x, that's squared minus 1. No, that's f of x. So where is my derivative? There's my derivative. So I've got x minus a and 3x minus 2 minus a, close bracket, math 3 given x equals, and the value that I want is 2a plus 1 on 3. And that gives me this expression, which is a minus 1 times 2a plus 1 minus a. And if I combine that bit, that gives me negative a minus 1 on 3. So negative a minus 1 on 3 times a minus 1 gives me negative 1/3 a minus 1 squared. This is positive, but this is negative. Negative times positive gives me a negative. So I end up looking like this. So therefore, there is my local maximum, and here is my local minimum. So as you can see, this is really a tackle-out question. Find the equation of the tangent of the curve at these points. I'm going to, well, I know that at this one, it's going to be y equals 0. But this one's going to be a gradient like this, so I'm going to use my calculator to do this. So I've got bracket x minus a squared bracket x minus 1, and I'm attaching a tangent at 1, and that gives me that equation at a, and that gives me the equation y equals 0, and at a plus 1 divided by 2. And that gives me that equation that I might try and simplify. That can. So, as you can see, I can write all those lines out with a y equals at the front.